Okay, this is section 3.2, linear inequalities in two variables. Okay, so first the definitions. A linear equation in two variables is of the form, well, we have an example here, negative 2x plus y equals 1, which is sometimes written y equals 2x plus 1. And the graph of this equation is going to be a line, the set of all points that satisfy the equation. Now, a linear inequality in two variables is of the form y minus 2x plus 1 or negative 2x plus y is less than 1. And in this case, the solution to a linear inequality is the set of, again, it's the set of all points x, y that satisfy, this time, the inequality. And in this case, instead of getting just a line of points, we're going to get a whole region of the plane, like half of the plane that will satisfy the inequality. So how do you graph the solution set to a linear inequality? Well, first, it's basically two steps. You want to graph the corresponding linear equation, and then you want to figure out, well, which side of the line, and that graphing that equation gives you a line, right? And then you want to figure out, well, which side of that equation has the points that satisfy the inequality. You want to include that side of the line, those points, and we usually just shade that region in to denote, okay, this is the solution set. So let me go through this quickly. So to graph the solution to a linear inequality, first you graph the corresponding linear equation, and then if you have a strict inequality, we draw a dashed line to indicate that the points on the line are not part of the solution set. And then if you have an inequality that includes the equal sign, a non-strict inequality like less than or equal to or greater than or equal to, then we draw a solid line to indicate that the points on the line are part of the solution set. Okay, so once you've drawn the line that is the graph of the corresponding linear equation, to get the solution set to the linear inequality, what we do is next pick a test point. As long as your line doesn't go through the origin, I recommend you choose the origin, x and y both equal 0, as your test point. Plug that into your inequality, okay, and see if it satisfies it. So for example, I could plug the origin into this inequality, and I would get 0 is less than 2 times 0 is 0, plus 1 is 1. And indeed, 0 is less than 1. So that point, 0, 0, satisfies the inequality. And so we know that all the points on that side of the line satisfy the inequality as well. So we shade this region here that includes the origin. We shade it blue. Okay, obviously you can't shade like that with when you're doing work with pencil and paper, and so we just usually crosshatch or use a color and crosshatch with colored lines or something. Okay, so here's an example. Graph the inequality y is greater than negative 1/5 x plus 2. I'm going to get my ruler out. This is a line with a negative slope and a y-intercept of positive 2, so it goes through this point right here. And I'm going to use the slope to generate another point that's on the graph. And the slope is negative 1 over 5. So if I run 5 units, I have to go down 1 unit in the y direction. So I'm going to run 5 units. 1, 2, 3, 4, 5. And then I've got to go down 1 unit. That puts me right there. If I do this again, I'm going to go run 5 units. 1, 2, 3, 4, 5, down 1. That puts me right there. Does the point 10, 0 satisfy the inequality? Well, when I put it 10 in for x, I get negative 1/5 times 10. That's negative 2. Negative 2 plus 2. Yep, that's 0. Actually, it doesn't satisfy the inequality because we have strict inequality here, don't we? So next step is I'm going to draw my line, but because I have a strict inequality here, I'm going to do a dashed line. There we go. Maybe I'll use a color here too. So I'll just do a quick dashed line. Okay. And now I've got to pick a test point. I'm going to always pick the origin if it's available to me. As long as your line doesn't go through the origin, it's available. So let's see, does 0, 0 satisfy the inequality? So is this true? Is 0 greater than 0 plus 2? No, it's not. Okay, so that does not satisfy the inequality. So I want to shade everything above the line, right? So maybe do some cross-hatching like this to indicate that the solution set is the region above the line. Okay, let's move on to the next exercise. Okay, graph the inequality negative 2x minus y is greater than or equal to negative 4. So first, remember to do this, I want to graph the corresponding line. And it's easiest to graph the corresponding line if I put it into slope-intercept form. So if you like, you can change this into an equation and then solve for y, just like this, negative 2x minus y equals negative 4, and now solve for y. And I would get negative y equals 2x minus 4. And then I would multiply both sides of the equation by negative 1, and I would get y is equal to negative 2x plus 4. Okay, and so I want to graph that line. Let's see here. Let's get the ruler out. So this is a line with a y-intercept of 4. Let's plot that point. And a slope of negative 2. So this means that if I run 1 unit to the right, I've got to descend 2 units. So for example, let me move the ruler just a little bit. This point would be on the graph, this point would be on the graph, this point, and so on. Okay, now let's connect these points with the, let's see, do we want to use a dashed or solid line here? Oops. It's a little tricky to get this exactly the right. That'll do. We want to use a solid line here because we have non-strict inequality. So a solid line. All right. And again, we'll use a test point. So I'm plugging the test point now into the original inequality, and when I plug in 0, 0 for x and y, I get 0 minus 0. Is 0 greater than or equal to 4? No. So the origin does not satisfy the inequality. Thus, the points that do satisfy the inequality are on the other side of that line. In other words, above it. So we'll do cross-hatching like this to indicate that all of these points over here are in the solution set. Okay. Next exercise. Okay, here we have a system of inequalities. The reason we want to be able to do this is to solve linear programming problems. That's what we're working to and working towards. And it's similar, except instead of just graphing one set, you graph two solution sets on the same set of axes, and we'll use just two different colors. So I'll use blue for this first line and maybe green for this second one. Okay, so the line that corresponds with the first inequality would be the line y equals 1/4 x plus 1. So that has a y-intercept of here at 1, 0, 1. And then I'll use the slope again to determine another point that must lie on the line. The slope is 1/4, so that means if I run 4, I rise up 1. So I'm going to run 4. 1, 2, 3, 4. I rise up 1. Puts me there. I run 4 again. 1, 2, 3, 4. I rise up 1. Puts me there. Okay, and maybe go 1, 2, 3, 4 in the other direction. 1, 2, 3, 4. Go down 1. Okay. Let's get the ruler out now. Connect these up. Let's see. And this is a strict inequality, so I want to use a dashed line. I want to connect all these points with a dashed line. So something like this. Okay. And now I want everything above this, but let's just plug in the origin as a test point to see does the origin satisfy. I claim it doesn't. So let's see, is 0, so I'm plugging the origin into the original inequality here, is 0 greater than 1/4 times 0 plus 1. 1/4 times 0 plus 1 is just 1. Is 0 greater than 1? No, it's not. So the origin, like I claimed, the origin is not part of the solution set. It's the points that are above the line that are part of the solution set. So I'm going to cross hatch maybe like this to indicate that we want all of these points in the upper half of the plane. All right, now let's switch to the green line. This line has a y-intercept of -2, which is right here, and a slope of -1/2, which means if I run 2, I descend 1. So if I run 2 in the right, I have to descend 1. That puts me right there, and then there, and then there. Oops, not there. Got the ruler in the way. Right there. Going the other direction puts me here, and here, and here, and here. Okay. Let me. Okay, this ruler doesn't want to move. There we go. Looks about right. Okay, and I think we'll use green here. And again, we have a strict inequality. Oh, it moved on me. We have a strict inequality, so I want to do a dashed line. Whoops. Let's do this in green. We want to draw a dashed green line through these points. And which side do we want to shade? Does the origin satisfy this inequality? Is 0 less than 0 minus 2? No, it is not. So the origin is not part of the solution set to this inequality, I want the points below the line. So that would be this region. Okay, and what do we see here? We see that the solution set is actually this region here. Okay, and this extends outward forever. Of course, we don't want to include the points on the lines, but you get the idea. So we have this weird little region in the plane that satisfies both inequalities simultaneously. And that is our solution set. Okay, let's move on here to the next exercise. Graph the system of inequalities. Okay, first I'm going to put these inequalities into slope-intercept form. I'm not going to leave them, and this is up to you. You can rewrite it as an equation if you want. I'm just going to leave them as inequalities and solve for y. So the first one becomes what? I get 2y is less than or equal to 2x minus 12 after adding 2x to both sides of the inequality. Next, I'll divide both sides of the inequality by positive 2. Don't need to flip the sign, but I get y is less than or equal, not the sign, the direction of the inequality. Y is less than or equal to x minus 6. And if we solve the next inequality for y, we get negative 4y is greater than or equal to 2x plus 8. And I can do the same thing, divide both sides of the inequality by negative 4, but dividing by negative 4 is the same as multiplying by negative 1/4, right? I got to flip the direction of the inequality, and I get y is less than or equal to 2 times negative 1/4 is negative 1/2. So negative 1/2 x. Negative 1/4 times 8 is negative 2. Okay. Let's see. So let's graph the first inequality. I want to graph the line y equals x minus 6. So that has a y-intercept down here of minus 6 and a positive slope of 1. So these points and continuing off in this direction here. Let's get the ruler out. And I want a solid line for this inequality. All right. Oh wait, no, I want a solid line. Okay. The next inequality, I want to graph the line y equals negative 1/2 x minus 2. Okay, and that would give me a y-intercept of negative 2, which is right here, and a slope of negative 1/2 means I rise negative 1 when I run 2. So I'm going to go down 1 when I run 2 to the right. So run 2 to the right, go down 1. 2 to the right, down 1. 2 to the right, down 1. Continue in the other direction. Okay, get my ruler out. We'll connect these points up with a solid green line. Okay. Nope. Oh, okay. I'll do the cross-hatching for the green line first. Let's see. Does the origin satisfy this second inequality? Is 0 less than or equal to negative 2? No, it's not. So I want everything that on the other side of the origin side, so I want this side. So I'm going to cross hatch over here. Okay, now what about the blue one? This one is y is less than or equal to x minus 6. Y is less than or equal to x minus 6. So does 0 satisfy this inequality? We get, is 0 less than negative 6? No. So I want this region. Okay, and let me see here. Our actual region would be this portion, everything in between the two red lines. Okay. There we go. Here we have a slightly more involved linear system of linear inequalities. So this is from your homework, actually, section 3.2 homework question number 9. I've copied the inequalities down here. We have the system of inequalities that you see on the left here, right here. And notice we have these two new ones. X is greater than or equal to 0, y is greater than or equal to 0. What these inequalities do is force us, all the points that satisfy x is greater than or equal to 0 and y is greater than or equal to 0 are in the first quadrant, or also including the positive x and y axes, and 0. So, and what I've done here is I've solved the inequalities for y. The first one, we got y is less than or equal to negative 1/4 x plus 8. So let's go ahead and graph that. Negative 1/4 x plus 8. So it has a y-intercept of positive 8 and a slope of negative 1/4 means if I run 4 points, 1, 2, 3, 4, I must descend 1. So this point will also be on the graph. 2, 3, 4, and 1. Okay. So let's connect these points up, and I have non-strict inequalities, so I'm going to use a solid line. Okay, now let's graph the next inequality. Y is less than or equal to negative 7/6 x plus 35/3. Well, let's see here. 35/3, what is that? 35/3, that's 3 goes into 35 11 times, right? 3 times 11 is 33. So 35 equals 3 times 11 plus 2. So 35/3 is 11 2/3. Okay, so my y-intercept is 11 2/3, but it's not even on the graph. So, we have a problem there. So I need a different starting point. So let's find the x-intercept. How do we find the x-intercept? Well, we set y equal to 0 because every single point on the x-axis has y-coordinate of 0. So I'll change this into an equation. We have y equals negative 7/6 x plus 35/3. And I'm going to set y equal to 0 and solve for x. Oops, that should be negative 7/6 x. So I'm going to add 7/6 x to both sides. Okay, and to solve this, I'm going to multiply both sides of the equation by 6/7. And I'm going to get let's see, so 6/7 here, and then 6/7 here. 3 goes into 6 2 times, 7 goes into 35 5 times, so this is equal to 10. Okay, so what this means is that our x-intercept is here at the point 10, 10, 0. And we want to graph this inequality now, or that the line that corresponds to that. So it has a slope of -7/6. So that means if let's think of it, -7/6, this is equal to 7/6. So if I go 6 units in the negative x direction, 1, 2, 3, 4, 5, 6, that puts me here. I have to rise up 7 units, so 1, 2, 3, 4, 5, 6, 7. Oh, that puts me right here on this point, at the point 4, 7. Okay, so now I have 2 points that I know are on the line. I can connect them with a line, and I'll use a green line for this one. I want to connect these 2 points here. Close enough. And this is also a non-strict inequality, so I'm going to use a solid line. Okay, now I need to find the region for both of these. Let's see, I'll do the blue one first. I'll do this one. Does 0, 0 satisfy the inequality? Is 0 less than 8? Yes, it is. So that means I want everything below the blue line. Oops, I'm kind of missing some of it. Good enough. What about the green inequality here? This one. Does 0, 0 satisfy that? Is 0 less than or equal to 35/3? Yes, indeed it is. So we want everything below this. So maybe something like this. Okay, so what is our region? I'll kind of outline it here in red. The region of intersection would be defined by this portion. I can do a little bit better than that. So everything below the two, and in fact, because we have these inequalities, x has to be greater than or equal to 0 and y has to be greater than or equal to 0, we can actually do even more exclusion. We can restrict our solution set to the first quadrant, and so I get this polygonal region as our solution set, and I can actually take off these red arrowheads because I don't really want those. Okay, and notice we'll see in the next section that these vertices of our polygon are going to be important in solving linear programming problems. So there we go. Okay, so I want to show you first how to do this in Desmos using the website desmos.com. So I have done this already for us in desmos.com, and then I'll show you how to use your calculator to do it. So let's see here. Okay, so I just put in the regular inequalities here. X plus 4y is less than or equal to 32. 7x plus 6y is less than or equal to 70. And you get a perfectly fine graph doing it this way. Notice that if I add in these inequalities, x is greater than or equal to 0 and y is greater than or equal to 0 with two more colors, I think it's kind of hard to read. You get a mess. You can still see the region. It's the darkest shaded region, but it's kind of hard to tell. You know, is this region, you know, which region is darkest? It's a little bit difficult to tell still. So instead of doing it that way, I mean, that's perfectly fine, but I think it makes a little more sense to, well, Desmos does allow us to get a nicer way of graphing this, and that is with this special kind of notation. If you solve your inequalities for y, then you can specify that y has to be greater than or equal to 0 in the inequalities, okay, or whatever it has to be greater than, okay. And then we can put a domain to this. We can, you can see after the inequality here, this compound inequality, I've added this restriction: x must be greater than or equal to 0, but in curly braces. What this does is it says, okay, we're going to restrict all the points that satisfy the compound inequality to points that have an x coordinate greater than or equal to 0. Okay, so we get the restriction we want. And if I bring these up, you'll see I get a much simpler graph that is it's much easier to see the region that we're interested in here. Okay, so the region we're interested in here goes from the origin up on the y-axis to the point 7 or 0, 7 over to the point 4, 6, or sorry, no. This point on the y-axis is the point 0, 8. And then this point is the point 4, 6, and then the point 10, 0, and then back to the origin. That's the region that satisfies all four inequalities simultaneously. Okay. So this is how you can use Desmos to graph inequalities nicely. Of course, you could just do it, you know, just doing this is probably sufficient as well. Okay. How do you do this with your calculator, though? Okay, let's take a look at that. So, okay. So let's see here. I want to be able to see the system. Okay, now I don't think all of the TI-84 Plus calculators can do this, but if you click on if you click on y equals, on some calculators, if you can cursor over to this part, if you can hit enter now and change the color of the line, and change, if I cursor down, I can change the line style by hitting the left and right. Right? I can do inequalities here as well. Let's see. Maybe I don't need the app after all, because this calculator does have an inequals app. But let's see if we can do it without. Let's see. So I want y is less than or equal to -1/4 x plus 8. So that would be that. And let's go up and change. The color's fine. Okay, so let's go hit OK. Okay, and now I want this to be, okay, so negative parentheses 1 divided by 4, close parentheses, x plus 8. Plus 8. Okay. Let's graph that. Yeah, that is not working like I thought it might. So never mind. I think you do have to use the app. So let's clear this. I'll change this back to normal. Whoops, go to enter, down. Oh. Okay, and enter. Okay, and then I'm going to click on apps. So you see the apps button there next to the math button. You need to click on the apps button. And you see choice 7, inequalities. Okay, this does allow me to graph inequalities. So I'm going to hit number 7. Okay, and it says here press any key to continue. I'll hit enter. Okay, and now I can, now when I cursor over, also up at the top you see on the far right there it says quit app. Okay, so it changes the plotting app a little bit, is all this inequalities app does. And when I when I hit the down, or no, sorry, when I hit enter, when I've got one of these things highlighted, it allows me to change it from equality to inequality. So there, that's what I want. I want y to be less than or equal to something. And the style there is good. Okay. And now I've got to cursor over and get into the region where I can put in -1/4 x plus 8. So we have negative parentheses 1 divided by 4 times x plus 8. Okay, and then the other one is I got to go change it into an inequality. Hit enter. Cursor down. You know what? I'm going to change this to green as well. Green. And then we'll change this to less than or equal to. Cursor down to OK. Now I cursor over to where I can put in the linear part. So I have -7 divided by 6 x, -7 6 x plus 35 thirds plus 35 divided by 3. All right, and then our window settings. Well, let's see here. What we want to go from, it looks like 0 for x. We want to go from 0 to 10, maybe 12. And then our x scale should probably be, this should be 1 tick mark every unit. What about the y minimum? Y minimum should be 0. Okay. Oh, I've got a y max of 1,000. We definitely don't want that. Let's change this to like, 12. And the y scale should also be just 1. Okay, let's graph that. And there we go. Okay, and then you can hit trace, and you can cursor over to find an approximate value for the point where the two lines intersect. Yeah, it looks to be the point 4,7 to me, which agrees with what we have on our other diagram here. Okay, so if you have one of the newer TI-84 Plus calculators, you can graph these inequalities, or just use Desmos. That'll work too. All right, and this concludes section 3.2.